Okay, so we can start. Thank you all for coming. My name is Miroslav Franc. I work for kernel team here at SUSE. This is not gonna be only my talk. I have Marcela Mašláňová, who is project manager for S390, and Nikolay Gueorguiev, who is like maintainer of S390 tools, with me here. And we prepared a presentation about S390. It's gonna take about an hour. So I hope it's gonna be interesting for you. I'm not an expert on S390. I'm a kernel maintainer on SUSE side for like 2 years, but I managed to learn something during that time, and I wanted to share something with you what I learned and what could be helpful for you if you want to like work with this architecture, especially. We are going to say some SUSE specific things, So let's dive into it, So what is S390? Most people say S390, but it actually IBM call it System Z or Z architecture. It actually stands for Z means zero downtime. That was the idea. It's probably not complete zero, but that's another story. S390x. X390x is a kind of Linux specific name for System Z, So IBM doesn't call it S390x, they call it System Z, or machines capable of running Linux. Only Linux and ZVM are called like LinuxONE, but we in Linux community call it S390x. Do not confuse it with S390. S390 was actually name of the architecture that was devised in 90s. It was actually 31-bit architecture. It was kind of a strange thing because original mainframes from like 60s, there were 24 bits. And when they came with extension in 90s, they used 1 bit for in the register to decide whether this is like 24-bit mode or 31-bit mode. So there's a reserved 1 bit for this, and as a result, you could address only like 2 gigabytes of memory. But at the turn of the millennium, they devised new architecture, like a Z architecture that is 64-bit. So in theory, you could address like 16 exabytes, but I don't think any machine has that, Well, I think it's a bit different than for Intel when they don't use the whole 64-bit for addressing. But in here, it's reserved for addresses. But for example, if I'm as a kernel maintainer, I deal with source code, in a lot of projects, not only in kernel, like the architecture dates back, the support for these architectures dates back to 90s. And in the past, they're still called S390, So, but we do not support original like S390, 31-bit anymore. I think for our latest products, I even removed or disabled in config like 31-bit support. So what is the architecture? It's a 64-bit, as I mentioned. It's a big NDN. It's it's one of the, it's probably latest commonly used architectures that's big NDN. Even power these days is little NDN or used as little NDN. I'm not sure whether architecture is still capable of executing. Probably is like a big NDN in big NDN mode, but this. It is possibly, but we don't use it. Like we have a little NDN everything, and this is the last architecture that is big NDN. It's actually, I don't know whether this distinction make sense anymore between like a RISC or CISC, but it's there's a lot of instructions. I counted. For how many instructions, depends how you count it, right? But I went for Vulkan internals because it's an emulator and kind of emulate S390. And there's a list of instructions, those that are implemented, those that are not. And there's like 1,800 instructions, Of course, not everything is pertinent to every generation. Like latest generation of System B is Z17, and some of those instructions are kind of specific, or they are only new generations. But I counted around 1,800 instructions, So this is their list. It should be like clickable link, hopefully, and it's in Vulkan sources on this thing. I heard, I don't know whether it's true because I've never actually seen it, but I heard that like 2/3 of the instructions are actually implemented in hardware and 1/3 in what IBM calls millicode, which is basically microcode. They have special names for a lot of things. So this is kind of also a link. It's probably not the latest version. I just realized before this talk, But this is very important document if you want to if you care about these low-level things. Maybe it's important for compiler people or people who do like low-level stuff or low-level debugging, like the architecture principle of operations. This is the link. Maybe there's some newest version, I'm not sure, but it should still give you like overview, like a list of like basic instructions and how everything is from like a low-level architecture standpoint. So if you are interested in the gory details, it has like 1,500 pages, so you can read this. I picked something up that I found interesting, like how compared to, say, Intel, like we probably are, most of you are programmers, so you probably know at least like Intel or x86. So how it compares, right? There are registers. There's this register that is called program status word, and like a top half, like 64-bit of this register is actually instruction pointer. And in the remaining bits, there are like which mode it is, or there are some condition code for conditional execution, and some bits are reserved, But mostly what you care about in this program status or PSV is instruction pointer. And you can like kind of, in GDB, you can print it, whatever. There are 16 general purpose registers, R0 to R15. There are 64-bit. There are 16 floating point registers, F0 to F15. There are also 64-bit. But there's some interesting thing that, for example, you can pair registers. So for certain instructions, so you can have like 128-bit operations, integer or floating point. And the pairing of registers is kind of interesting. You cannot use like any two registers, but you need to like pair the correct register. For example, R0 and R1 can form like a 128-bit integer, and R2, R3 also, But if you pair R0, R2, it's not gonna work, Similar is for floating point, but the pairing is a bit weird. It's different. Like it's F0 and F2 instead of F1. So you kind of pair even and odd registers, and it's kind of funny. I remember I once discovered one bug in Valgrind where the JIT in the Valgrind was generating like a wrong pair of register. The register allocator was broken, and it actually Valgrind was killed without any warning because it generated like, I don't know, F0 and F1 or something, and it doesn't pair, So if you are doing some low-level stuff, maybe that's of interest to you. There might be also like vector registers, which are 128-bit, and there's 32 of them. Another interesting document for programmers is like LPABI, like S390x extension. You will discover anything like what stack looks like, the calling convention, the register usage, relocations. There will be even some examples like how it works. How are bit fields and basically all the low-level stuff we care about when we program on Linux. I have some this is maybe a kind of filler slide. I have some like general purpose registers which are like saved or not volatile, which are volatile. So there's this same for floating point. It's basically taken from the document. And I have like some register usage, for example, on Intel return addresses push on the stack. In here we use link register. are 40, you know, and return values depending whether have integer pointer or floating point or some SIMD thing you have here, and like arguments are in these. And instruction pointers. So whether you care about that, you might find in these two documents, you know. Now, I would like to move a bit from the low-level things and tell you some overview about like virtualization, because like mainframes were virtualization before there was virtualization, right? And this could like you could draw a more complicated picture, and you could certainly have a more complicated setup. And mainframes can run some like deprecated or not deprecated, but some legacy systems like ZOS and others. But we don't care about them. We are at SUSE care about Linux, so this is the only thing that is pertinent for us, you know. And the only thing that makes sense, you can certainly nest the virtualization like some Russian doll, you know, but it doesn't make any sense, you know. This is what actually makes sense. You know, I draw this on Krita. I'm not very good at drawing, you can see that. But this is basically outer box's mainframe, right? Inside there are like 3 boxes, and these represent LPARs. LPAR stands for logical partition, and it's basically the closest you can get to kind of bare metal, because there's no bare metal S390, everything is virtualized. But this is first level virtualization, you know, LPARs. They have, I think they have dedicated memory and a CPU that can have shared or dedicated, whatever, but it's the closest thing you can get to bare metal. And in here I have 3 configurations that like make sense for us that we use at SUSE. Either have LPAR with Linux, presumably SUSE Linux, or you can have a ZVM, which is kind of hypervisor by IBM. It's a kind of operating system on top of which you can have virtual machines. These are also Linux, right? And you can have Linux with KVM, like running virtual machines. So if you are lucky and you have an LPAR, good for you, you know, you have something that is very close, but most machines, because we have actually only 2 mainframes, like a Z13 and Z15, and you have to partition them into a lot of pieces, right? Because everybody wants some piece, you know, of S390. So if you don't have like a LPAR, you will have some VM. I think Marcela will talk about later about some self-service if you want to debug something on mainframe, you know, have some issue, something doesn't build or something misbehaves. You probably want to reserve like a piece of mainframe, and that is totally possible. We have I always forgot the name, is ICIC, IBM Cloud Infrastructure Center. Oh, thank you, Nikolay. And that's basically the thing. You go there and you reserve a virtual machine, and this is what you will get. And you can have SUSE Linux there, and you can debug your thing. If you have LPAR, you access it usually via something called HMC, which is kind of it's a kind of a computer that runs some web UI, and you can access it via web browser, and you can access console via web browser. If you have like a ZVM, you access console via ZVM, and this is actually something called 3270 terminal. It's a bit dated, but I don't find it that horrible as people say, so I'm gonna later say something about that, you know. And the last setup, like Linux plus KVM, I don't think we currently have something to offer to developers like that. But it's used, I think, in our build service, like OBS, IBS, actually running this setup like Linux. You have a builder, and it spawns like a virtual machines when you build like a Rust or GCC or kernel or whatever, you know. So this is like what makes sense, you know, and what we actually use when it comes to virtualization. Yeah, so another thing, yeah, this is kind of ad hoc because, sorry about that, we don't have anywhere time to talk about everything, so I'm just picking bits and pieces. I want to tell you something that might a bit surprise you, especially if you do something with kernel, is that there are actually two bootloaders, two kernels, two initial RAM disks, like what gives, you know. The thing is, the mainframe or ZVM is capable of booting only like something called ZIPL. ZIPL stands for Z Initial Program Load, I think. Yeah. Yeah, I have it there. Sorry, I'm not reading slides. I'm too busy to focus what I wanted to say. This is actually modified Lilo, Linux loader. If you use Linux for like 20 years or more, and maybe you remember we used to have that before group took over everything. So this is it still lives there. It's a bit modified, but it's this ZIPL bootloader. And the only purpose of this ZIPL bootloader and this kernel we put there and this initial RAM disk is to actually run user space group, so that with that user space group you could like spawn kernel that's gonna run. You can actually boot the operating system. You know, most of the time you won't care about ZIPL. You will just do the grep thing and you will be oblivious to it. You know, but sometimes when the kernel is broken so badly that it cannot even spawn the group, you will start to care and you will need to like modify the ZIPL. Unfortunately, I don't have a command for how to do this, but it's quite simple. So you just need to be aware that it's there actually, you know, and not be surprised, because especially if you are manually updating kernel, the ZIPL kernel will stay the same, and you might be confused about it. I remember I was when I first hit it, you know. So just be aware that there are like two bootloaders. Now I have some example like how to do cross compilation. When it for example for kernel, you just install cross compiler, right? And you put the thing and you cross compile it. To be honest, I've never tried to like boot kernel that will be cross compiled, you know. But because I don't trust cross compilation that much, I basically use it only to quickly check whether something compiles, even, you know, because sometimes you apply patches and you are not sure. This can be actually faster, right? Because we don't have like that many mainframes and the resources are limited, you know. Average like VM you get will probably have something like 2 gigabytes of memory and something, unless you request something bigger. So it will take like half an hour to compile kernel. If you take some oversized like Intel machine with, I don't know, 160 cores or whatever, I don't know how many memory, this can be actually easier accessible and faster, you know. So you can cross-compile for S390, certainly. You can, another thing, if you don't know what to do, is to simply build it in OBS or IBS. What I wanted to like just pick out is that this is how we built our kernels, right? Is that if you don't want to like build services kind of limited resources, so you don't want to like spawn build and build everywhere. For example, for ARM, if you care only about S390, so you can limit it to only S390. And by default, there's no debug info, which is maybe a good thing because it takes a lot of space, takes a lot of time to generate. So by default, the debug info in our scripting is disabled, but you can enable it here. If you want to have a debug info, you want to debug, I just wanted to point those things out, you know. Okay, now my favorite topic, like 3270 terminal. If you have like a virtual machine on a ZVM, this is what you, how you access like a console, you know. The 3270 is a bit dated and it doesn't work like modern terminals. Modern terminals were very interactive, but this doesn't like, if you as you type characters, it doesn't do anything, right? It basically you send, it's basically a web page before there were web pages, like the old web pages, you know. It's kind of a form and it's divided in fields. And you fill in those fields, and you click submit, you know, as the internet used to be, like good old internet, right? So this is like, this is it, you know. You basically enter, and it will submit the entire screen advanced, you know. Later I will tell you something about logging, how you can enable logging on this, and this is very useful because logs, you can grab them, you can give them to somebody more knowledgeable, and it's generally useful for debugging. So in here, that log will look weird, you know, because it will have like screens. It will look like series of ASCII screenshots, you know. But it makes sense if you think about it like as a one big form. So this is like example how it looks like, you know. I usually use dark background, but it's not good for presentation, so I have to like switch to something light. This is how when you try to log in, you enter user ID or password, and you can log in on the console. Maybe if time permits, I will tell you something about. I will give you some show example, but I'm not sure whether there will be time. So how to handle it from Linux? You know, you can zipper install x3270. This is like a RPM package. You can install it on Tumbleweed or Leap or whatever. There are some other implementation of this terminal emulator, but they all suck. So I recommend you to use x3270. There are two versions in it. There's a graphical version, which personally I don't recommend. I know that Nikolay and Marcela are using it. It's using these Athena widgets, you know, if you remember, like Xbill or Xfig, you know, that's the same thing. But it's only for the menus, you know. Or there's a text version, which I like personally more because it's there's more seamless integration with Linux terminal as we are used to it. So if you are comfortable with Linux terminal, I recommend the text version. The package is still x3270, but the text version program is called C3270. Now there's a lot of options. Usually what I do is you will get some like where to connect, you know, to this serial console. How you get it is maybe up to Marcela or somebody else you get access from, but you will have some IP, you know, and so you can set this in this configuration. You can like set the name you want to use, you know. Usually use primary. That doesn't matter. There's an IP and port, you know. Usually, by default, this is kind of silly, but it actually uses telnet connection, right? So you connect to port 23 unencrypted. There's a way to use like TLS tunnel, in which case you should prefix it with uppercase L colon. If you want to ignore like certificate, you can put Y, and maybe to some other port, and then you can do like C3270 and the name, you know. Other configuration is you can have in your home, and yeah. Now I have slide about what do you do when you connect, you know. When you finally connect, you put your credentials. You will have two modes basically. One is called like CP or control program, which is kind of you will be basically talking to that VM, and other is like a VM mode, which will be your Linux machine, and you need to like make sure in which mode you are because. Only in this VM mode it will look like a Linux. If you are in CP mode, you can type like some ZVM commands. Like I have some examples with this. You can query like how many you have, what disk you have connected, CPUs. Storage in IBM speak is I think like a RAM or memory, you know, like a. Or some crypto cards, whatever. There's like the entire like document that describes what you can do with this. And basically, if you are in CP mode, you know, you can just type query virtual DASD, for example. You know, you have to do this. If you are with a VM mode and you want to temporarily do this, you need to prefix it with this #CP. You can switch easily between two modes. If you are in CP mode and want to go to VM mode, you type begin or just B. You know, and if you want to go back, you type just #CP, enter. You know, and then you can switch between two modes. When it comes all the like ZVM commands, you can also invoke them from the Linux itself if you are connected via SSH. Instead of this CPU, use vmcp command that is, I think, part of S390 tools. So yes. Booting. Like you will probably have a disk connected. Maybe Nikolay will tell you something about how to enable, disable disk and how it's handled. But you will have basically Linux installed on. Hannes have some.
This hash CP.
Maybe can you go to the.
Yeah, maybe this one. This hash CP is actually quite dangerous because you can execute it when the system is running, i.e. when your Linux guest is running. That's precisely the idea of this hash in front. So when you type this, hash CP IPL 150, while Linux is running, guess what happens? You do a reboot.
Yeah, I know.
Maybe for next time you should probably leave out the hash there, because then the command won't work if you're on Linux mode. Just so maybe, because that's actually quite dangerous.
Yeah, it is. It is certainly dangerous. Sorry, maybe I shouldn't have put it in the slides. Yeah, you will get rid of everything and boot from. Yes, maybe you can have just in CP when the system is down. Maybe I should have mentioned that. Yes, maybe I would have gotten into it. I don't know. Sorry about that. But anyway, you boot from disk 150. Depends, you know. At SUSE, I know that Inno Krumraj, who unfortunately retired, had some convention that we usually put systems on disk 150. It doesn't have to be true, but for VMs, it's sometimes is. I'm not sure what convention is for the cloud infrastructure. Maybe Marcela knows. But you need to provide the number of the disk, and then you can do IPL 150, and you can boot your Linux, you know. One other thing is that I keep stumbling over is that, you know, I accidentally click somewhere and the terminal is locked, it doesn't work, so I just press stop, you know. Yeah, it's correct. I already said that. TLS, tunnel, you know, the L prefix in here. It's a good idea to enable like screen tracing, because if you want to, like, if you did something, it's a good idea to send somebody a log. You can either use, when you invoke this C3270, you can set a screen trace here, or you can put it in your config in your home, a screen trace through whatever works for you, you know. And then in TMP you will have some log. It will have different number, right? But you will have some log, and it will be this series of ASCII screenshots I talked about. Of course, by default, I think C3270 is emulating like version 4 of this terminal, which is like 43 times 80 characters. If you want to do something bigger, which I assume you want, you can use this oversize and put some arbitrary number, which might be good because you will see more things. But there's unfortunately a limitation that it's only 14 bits, right? So this product must not exceed 2 to the power of 14 number. No. I have no idea why, but it's a legacy thing, you know. Yeah, that's another important thing. And please never just close the terminal emulator. Never. Just first disconnect, you know. Disconnect from the terminal, and then you can close it. Because what happens is, if you don't do this disconnect, you know, is that you will remain locked in, and you won't be able to immediately go back. You will have to wait till your session will expire, or somebody who has more rights on that VM will kill it, you know. So always like disconnect first before closing this terminal emulator. It's important. Now, there's another thing, kind of special, as terminal will keep producing something, it will like fill in the screen, right? And at that point, like your VM will stop, and it will just be hanging out until some timeout is again like reached. I will show you later on the screenshot, but it will in the right bottom corner. It will show this more. You can kind of disable it with this command. You can set it 1 like a delay 1, and yeah, and it was the other one. I kind of forgot, but I just use this without thinking much. This is the default. That's how you restore the default, and this is what I recommend unless you want to wait like 50 seconds, I think, right? Yeah. So this is like how I have Linux via this 3270 terminal. This is I'm in CP mode, right? So this is this running is VM mode. I'm in Linux mode. I can type Linux commands. Here, this CP read, I'm in this control program mode, and I can execute like the commands, like the square virtual CPUs without that hash CP. And this is like the more example where basically I typed cal and it didn't fit, so I need to in C3270 I need to type clear keyboard or Control C, and it will like scroll down. You can also scroll back up, and this is one of the screenshot that you will have in the log. Okay, so I have one example, that thing that I tripped over and I wanted to mention is that basically, what do you do, for example, if you want to modify, if your kernel doesn't boot, and you want to modify kernel the command line, right? How do you do it with like a 3270 terminal? It won't work like your typical Linux, right? So you say you type like IPL 150, you boot, you wait for the grab menu. You type E like edit, enter, and then what now? You cannot just click somewhere or use keys, You actually need to like find type like let's just say coordinates, like where you want to edit something, like this caret n. It's really caret n. This is like a new line, 5 times new line, and caret E is like Control E. It's like end of the line, So that way I can switch like at the end of the command line because it's on the 5th line, right? And it's at the end of it. I want to append in the binit bash because I forgot my password, whatever. And then caret X like boot, and then I type enter, and I just edited grep in 3270 terminal. It will get some time to use to it, but it works, and you can like yeah. If you want to know more about this, we have some documentation. This is a link which I hope it works. How to manage how to do it, but it's some basics. This is what will look like before hitting the enter, right? So you will basically want to append this here, this init bin bash. Okay, so and maybe that's the last slide, right? I have like some people use Work Manager, others don't. I sometimes find it's useful to run this on my laptop, when you can use QEMU. And I'm kind of old-fashioned, so I use some commands. I reserve the disk space. I install Tumbleweed if I want to do test something from upstream, and I just boot it. So these are commands that from my notes that I know that work. You can like tweak them. And this is basically everything from me. Now I will hand over to Marcela Mašláňová, and she will tell you something. And yeah, you have 26 minutes left.
Great. So yes, I'm surprised how different.
Yeah.
Surprised how Mirek used these tools. I'm trying to use more graphical tools. So you might think what we are really doing with S390. We are cooperating with IBM, and they are sending us a lot of patches, and mainly Mirek and Nikolay need to incorporate them into kernel and other specific tools. But sometimes we are requested to do something interesting. So the previous year, I think we finished images. They are in different formats and they work pretty well. For example, the cloud images we are using in our own cloud infrastructure. And those QCOWs are, I think, used by QA. So that's pretty good. The next thing we did this year was secure execution, because everything on Z is different. So we are calling it secure execution. x86 is calling it confidential computing to have some fun. Markus Schäfer wrote the secure execution into Kiwi, so we are able to build images which support it. But it's pretty complicated because you need to get some keys from IBM, you need to have your own key. There is a test build of image currently, which works on Tumbleweed, and I provided a lot of documentation for IBM. It was possible to do it before by a lot of commands, but yes, then we are getting to something like Mirek showed us. It's pretty complicated and easy to do a mistake there. The next pretty thing we did this year was improvement of Yast installer. So S390s have cryptographic cards and they can be used for, well, you can communicate with SSH through the crypto card to make it faster or more safe, let's say. So we can also encrypt our disk through it. And it looks like this. So we are using LUX2, that's the pervasive volume encryption, because why don't give it different name, right? You create some encryption password you usually use, and then okay, can't find. You can use ciphers which are in the cryptographic card. So I was able to set up these two, so we have these two in our testing, and it works pretty well. Yast team was great to do it because, well, it's different technology and it was a lot of work to figure out how to do it. So that was for SLA 15, and in SLA 16 we are also trying to do some stuff. I'm mainly testing a gamma every release, every beta, alpha. So I guess now we are in good point and everything seems to be working, but the encryption which I showed you is not there yet. I believe we will finish that, but not yet. And there are some difficulties with setting up disks, but I guess we will do better. Another big change will be there is no VNC, so it took a lot of effort to fix RDP, GDM, and Wayland. This combination does work on S390, and to my surprise, people are preferring it to SSH or other way of connection. So yeah, this should work now. Our colleagues provided a lot of fixes there. Then we have cockpit. So there are some obvious bugs like the reverse order of IP addresses and such stuff. So they fixed that and I'm very glad for that. And it seems to be interesting for customers. So let's see what we will add there. And I was able to finally drop Plymouth. That's the thing which will show you graphical interface while you are booting, and it can request passwords. So this was completely useless on S390, especially if you encrypted whole disk, you weren't able to decrypt it ever again. So I should say that I'm technical project manager and I communicate with IBM and our engineers and testers and support, but I'm also administrator of those machines. Yeah, I'm quite new to it. I'm not doing it for 2 years, so I'm really happy that we have someone in our IT who knows more about it, but he's very busy, so it's usually up to me. I wrote Confluence pages, which should make it easy for people. I wrote it when I was new, so it should be pretty straightforward. When I file a bug for you, you will usually get these 2 links. I got from engineers some often bug fixes like the reverse order of bytes and such stuff. So it's often very easy. So this is our cloud infrastructure. We have we have LPAR on which is running ZVM. On top of the ZVM is OpenStack, and on the OpenStack is running this. It has graphical interface, so it's quite easy to get a machine, and it's using those images we talked about before. So it's pretty quick. I think small machine could be done in 2 minutes. So you have something to work with. For example, our support is using it. These here are machines which we are usually providing. We finally have /16 there. That was some work to make it happen, but it's there. And there is a long user documentation. You don't have to be afraid because you need to read only the top and upload your key. The rest is for people who would like to connect directly to ZVM and debug something with booting or do the manual installation of micro. That's all possible. And on the Slack channel, we have a lot of smart people who are using it and debugging it. So they will definitely help you. So the next thing is, well, we had disagreement with Mirek because I don't like command line. So I do it like this. It does work. I tested it on some images we produce. It's just slow when you are running it on your laptop. And I'm using X3270, not the command line version. And I should probably change the colors. So in the case you need to do something like fix booting, you need to go to this. You need to install it. So this was for the, we call it a PARM file, and it defines what should be done, how the VM should be set up. So this was the easy way for /15. If you just want to define the installation source, but you can define everything, which cards will be used, what disk will be used. That was just the easy thing. You can also do more complicated stuff. This one took me some time to figure out because I needed to install that file. So the example is there, how to put it there. But you usually don't need it. I'm nice and I usually provide installed machines because I guess this is pretty scary. So this is another example for /16 installation. That's changed because YAST could ask you questions and you can provide input with your information, how the machine should look like. Now you need to know before all the answers like IP address or name server, disks. And this should be example probably of, yeah. So another change is that we have different images for /16. The previous one was for live installation. That's easy. But if you want to install everything, you need to define another parameter and get everything from your FTP location. Well, it's documented for customers, so I hope they will be happy.
Marcela, one question. Okay. So how slow is slow for these VMs? I was actually thinking of testing power in OpenKube because you don't have,
I don't do
hardware.
power.
Yeah, no. They said like it takes like 6 hours to install like minimal system, like with the emulation. Is it like that bad, or is it like can you install like /16 within 2 hours if you run it in virtual machine on your
What virtual machine?
No. You were showing that you can actually emulate s390x like with QEMU, and you can.
Okay,
So does it take
so
like 2 hours, 6 hours? Like how long does it take to install like minimal system on it? Is it usable?
Like half an hour.
No, that's
I
perfect.
think half an
So
hour.
It's not that bad. It's not that bad at all. Okay, cool.
But QE has instance on S390, so they have their KVM and they run their test there. And they can ask me for hardware.
One thing to keep in mind here is that IBM is switching over, or apparently switching over most of the development work off from ZVM over to QEMU.
Okay.
So they put in massive effort to provide either the same devices or an abstraction for these devices into QEMU. And that's with the OpenShift effort, because, you know, IBM and so on, Red Hat, and everything has to be OpenShift, and OpenShift is QEMU based, so everything has to be QEMU nowadays, which means that QEMU for the mainframe emulation is actually getting useful. You do have different devices though, because they didn't manage to emulate the entire hardware. So you do have different hard drives. I mean, you have the normal VDA ones, not the CCW ones, and a different console and everything. But other than that, yeah.
The biggest use case is testing if it boots. You know, if I can actually stop the image.
Yeah, that's actually a very, very good use case. Yeah.
Thank you.
Yes, we are testing it. Sadly, I'm testing it. So the worst possible case that you need to fix something in grep, probably. So then you will need LPAR. Yes, Mirek mentioned that we have HMC console, so it looks like this. We have a lot of them with some resources, but I can't give every developer their own LPAR because like we have limited storage and disks. So this is example of what we work with QE. We are currently testing installation of LPARs because customers still use ZVM mostly, I guess. But we would like to make sure that they are able to install LPAR with SLA16. So we use the ZL09. You can see here what is running there, that we have Linux here. On the next one is running our cloud infrastructure on ZVM. And there is a lot of options, but people usually don't see them. This is my administrator view. So no worries, you would break anything. There's just not enough button to break anything. That's up to me. And there is also documentation how to install it. And that's everything from me. So next is Nikolay, who's working on a lot of tools from IBM.
Hear me? Okay. I will present you IBM's S390x packages, which I'm maintaining and supporting. So I'm present. Let's say I'm showing some kind of toolkits. Let's say there are many packages that I will present. I have not so much time, so I will be quick. This is my name. If you want something, you can connect me to the email address. So what is S390x actually? It's IBM mainframes. We don't have any others. It's IBM mainframes. So S390 tools is the main package. When you have a ISO for S390x, you have this S390 tools included. So here it's a GitHub link. You can check it, and there is a README file. You can find any explanation for every tools that we have. And also we have if you Google this in the IBM Z, in IBM's, I will mention IBM in every slide. Let's say you can see the list of commands that you can be used on a Linux on IBM Z series. So I have listed a few commands that are let's say used for the Z configuration. One of these commands with the CH at the beginning, they are changing something. Like this old way was a change CCW device. You can do device online and offline. And you have a ZDef right now, which is doing configuration, automatic, let's say, active configuration and persistent configuration. So these commands with ls, these are the list commands that you can see. List does this, list Ethernet devices, list cryptographic devices, list FCP devices. So I have put some kind of commands. This is how you can do. This is an LPAR mode. That's the address of the disk. So how you can do online of the disk. It's enabling the disk, or you can have -- online. This is how you make the disk offline. You do this disk offline, and this is a network adapter. Let's say you can use this hexa. Sorry, these are hexagraphic. So you can specify range of disk range of addresses. So the newer way it's to have this enable and change, which is changing the active configuration and the persistent configuration. So you can have a similar command as this one. Enable does this. and remove. You can define is it persistent or not. So list of all Z devices that you may have. It's LSZ devices. So if you want to know only the devices, you can issue this command. If you want to see all SCSI devices, available hosts, ports, devices. So this is the command that you can specify. This command, it's usually to see all devices, including offline. So because if you do not enable the devices, you cannot see them online. So you need to do this command to be able to see all devices that you have. This is all network devices that you have that you can configure, and these are the configured ones. So there's a book which is called Device Drives Feature Commands, which is IBM, and there is a PDF. You can download this book, and it's always like a Bible for everything for Linux, and it's for SUSE Linux Enterprise Server. So it's a special book IBM wrote about SLES. So also, if you're interested in them tools, you can use this link, and there is a PDF file. Also, you can download it. So this was in short about s390x. There's another tool called SMC. It's called Shared Memory Communication. Shared memory communication, you have a memory, or you have two LPARs, and you have a shared memory between them, and you can communicate like an entire shared memory, like a SMCD. This is a direct memory access. And you have another way, it's a remote direct memory access. So it's a RDMI over convergent Ethernet, ROSI adapters. So I have put some kind of commands that you can see. This is SMD commands. All commands for SMC are prefixed like this. So this is the list of devices. This is SMCR link group and device show all. This is one slide for that. QSLIP, this is the library that you can use for receiving system information of the system. So you have a in this header file, you can see what kind of reports you may receive, and you can have a test program, which is a QC test. So you can use this the test program to be able to find the information about the system. Open Cryptokey. This is a package for cryptographic. So it's a suite of packages. So this one is Open Cryptokey. What is Open Cryptokey? You see cryptographic interface. It's available for all architectures. So there's another part of this. It's a library of IBM cryptographic architecture, libica. Sorry. There's two commands that I use, IK-info and IK-stat. So this is IBM's also link where you can find the documentation about called Libica programmer reference. So you have this OpenSSL engines and provider. So engines are available only for OpenSSL version 1.1. We have it in SLE 15. We still have this OpenSSL, and we have let's say favors. With OpenSSL 1, and we have OpenSSL 3 also. And for OpenSSL 3, you need to use IBM CA provider. There's another library called for protected key library. It's a library, you can use it, and there's a header files that you use. There are some function that you can use. So libzdn, this is, with every presentation, you need to have something for AI. This is my presentation for AI. It's so-called IBM Deep Neural Network Library. And there is no documentation for Linux, but this is for ZOS. And if you go to this document, you can see what kind of function you can use and what you can do with this toolkit. And there's another toolkit about the SCSI over fiber channel devices. This is a hardware. You have some kind of header files about functions that you can use. Yes, sorry. You know
Why do we still have that?
IBM requested it.
Why did it request it?
Because they are using something on it and they have requested it. Yeah.
You're the only one left doing it.
Yes, and the idea is that there's a newer version. They are preparing a newer version of it.
That makes better how exactly?
It is not better, but it's
exactly.
there.
Marcela, topic for next time.
Sorry.
No, because that is a horrible thing. So the HBA AP is actually a standardized thing, which the T10 committee, i.e. the SCSI committee, defined back in them days about, 15, 20 years ago. Since then, no one used it, but IBM thought a clever idea to latch upon that one for their management tools.
Yeah.
So they're literally the only one left doing it.
Yeah, but they have requested it, so we have a Jira ticket about it. I'm showing it. Sorry. And as a, let's say, cherry of the ice cream, I will present you this X3270. This is a Model 2. It looks better. And here you can find more information about X32 on this side. And there's some wiki page where you can find information about X3270. So that's it. This is my presentation. We have 5 minutes for questions. Sorry.
So questions? Or praise that we are doing it and you don't have to.
Thank you. It's many patches for it, and also thanks to him also.
So adding new arguments in Grub reminds me of Emacs shortcuts or Emacs key presses, because I think that's exactly it. Control
Yes,
N,
it's so awful.
Control N, Control E. It's not that foreign to me. The part that is foreign, that you have to enter it as a string, that's strange.
Yeah, if you already know Emacs, it's easier.
Right,
Maybe you can
right.
meet me.
Because I've encountered on certain serial consoles, even on Intel or AMD, you sometimes cannot use the arrow down, so you have got to press Control N either way. So my comment, it's not that bad.
Yeah, I think so too.
It depends.
So we have like 3 minutes. So any other question?
Of course. Which way do you prefer for deploying VMs? The the IBM provided tool, or having our own? Well, you're the manager, Marcela. Don't be shy.
What do we do?
Yeah, no. That was the question. What do you prefer? Would you prefer any developer who wants to develop anything on S390 to request their own VM, or to go via the self-managed tool for the automatic deployment via OpenShift?
That's not OpenShift, but
Whatever.
I would prefer VM if they go for VM, because I don't have to do anything.
Okay. Well, you still have to list this all out, which VMs are where and who has them, right?
No, they are, I guess, borrowed for 30 days, and then you will be warned they will be erased.
Who warns them if you don't do it?
Like in this ICIC, if you don't access it for 30 days.
Okay,
it
so
will be erased.
that was precise my question. This IC, so you do prefer developers using the ICIC?
I don't, but
Yeah, no, that was, I mean, that's my
But he has a real machine,
So-
and I can't give real machine to everyone.
No, that's fine. No, that was really a question. So basically, you do prefer using the ICIC tool?
Yes.
Oh, right, that was my question. Yes.
okay. So 1 minute. Last question.
So we are happy.
I hope so.
Yeah.
Thank you. Thanks.